Hey, hello everyone. We are back with the 2020 Latin American Space Challenge Conference. We are ending the first day of the conference with a great presentation of Ricardo Freire. Ricardo is a Brazilian. He is a master's in space engineering by he will talk more about his degree. I forgot the name, but
University of Rome.
yes, thank you so much. But the main detail is that Ricardo will talk about satellite operations and the Brazilian Space Operations Center. It's something very interesting because mainly Ricardo has, I think he has the control over our geostationary satellite, the SGDC. So this is going to be a nice presentation. So Ricardo, thank you so much for your time, for your presentation. Thank you for accepting our invitation.
Hello, Calvin. Hello, everyone. So it's a pleasure for me to stay here and talk a little bit more about satellites and my job. And all the conference is awesome. So congratulations to you and all your team.
Thank you. Have a nice presentation.
Okay, so let's start. So as Calvin said, my name is Ricardo. I am an aerospace engineer. I work at the Brazilian Space Operations Center. There, I am part of the flight dynamics team, and we perform station keeping maneuvers and collision avoidance maneuver. In addition, I work as a project manager in several projects of the Brazilian Air Force. And today, I will talk a little bit about satellite operations and the Brazilian Space Operations Center. So let's begin. All right, so the Brazilian Air Force has a lot of different commands, and one of them is the Brazilian Aerospace Operations Command. So the Brazilian Aerospace Operations Command is, of course, a Brazilian Air Force organization, and here there's a brief description of this command, which is a joint operation command permanently activated and responsible for the planning, coordination, execution, and control of aerospace operations, both recurring and occasional. So this is a brief description of this command. It is available online in public domain, of course. Clearly, I am not authorized to bring here classified information, so everything that I will say here is available online. But of course, that I will talk a little bit about satellite operations based on my own personal experience. And the Brazilian Aerospace Operations Command has different centers as part of it. And one of these centers is the Brazilian Space Operations Center, called COPE. So the Brazilian Space Operations Center, COPE, was built as a partnership between Telebrás and the Ministry of Defense, the Brazilian Ministry of Defense. And there we operate and monitor the geostationary defense and strategic communication satellites, the SGDC, as Calvin said. And the satellite has a dual application, a civil and military one. So using Ka band, we are able to broadcast connection in all Brazilian territory. And using X-band, we are able to process information related to defense and government areas. So here is a picture of the facility, the Brazilian Space Operations Center, here in the right, in the bottom. And yeah, this is a pretty amazing and incredible building with a very beautiful architecture. And it is not only beautiful, of course. This building has a Tier 4 certification, so it's one of the most and the highest level of technology that we have.
Okay, guys, we are back with Ricardo. Ricardo established his connection Everything is okay now. So let's get back to Ricardo's presentation. So Ricardo, the word's yours. So go on. Thank you.
All right, so I'm really sorry about that. So let's try to keep on this. All right, so I talked about the Brazilian Space Operations Center. I talked about the facilities, and here we have the satellite antenna that we use to perform the telecommand and telemetry receiving of our satellites. And here's the building. I said that the architecture of the building is in a format of a satellite. So we have 2 solar panels here and the satellite body here. So it's a very impressive facility. And we have a backup facility in Rio de Janeiro, which is a replica of one of these buildings here. And of course, to keep our operation working every time. All right, so I will talk a little bit about space operations. And I will start here talking in a general way, then we are moving on. So when we talk about satellite operations, we must have a 24-hour, 7 days per week activity, so we never stop. And we have 3 main segments. We have the space, the ground, and the users. And of course, we must guarantee a high reliability and availability of our system and of our operation. And to guarantee this, we usually use redundant equipment and systems. So here there's an image representing all these operations. So we have the antennas to receive and to send telecommand. We have the satellite control building. Usually, as we have here in Brazil, we would have 2 facilities, 3, and of course we must have communications between them. And we have the satellites, of course, the space system, and the users. And all of these segments are in a communication between them. So about the ground segment. So I will go further here about the ground segment, which is one of the parts which is most related to what I do, to my job. And I will talk about some basic elements and people who work in a space operations center. So the ground segment is one critical element in satellite operations. And you may not believe, but sometimes it's neglected in satellite projects because it's very common. We spend a lot of time and we spend a lot of efforts thinking about the space segment. But we sometimes forget that if we do not have a very good and reliable ground segment, we will not be able to operate the space segment. So the ground segment is a very important part. And we have a lot of elements to guarantee that the ground segment will work properly. So we have the ground communication network, which is part of the computers and the storage and all the communication between them. And so it's something very important. If something of these ground communications fail, we will have a real and bad problem. We have the RF equipment, the radio frequency equipment. So we have antennas. When we're talking about satellites, we must have antennas. There's no other way to communicate to them, no matter the satellite application. So we must have antennas, and we must have amplifiers. And here we have some equipments that are really important in the ground segment. And let's talk about some people who work in the satellite space operation. So we have the satellite engineer, which is one of the most important engineers because the satellite engineer stay all the time following what is happening with the satellite, checking all the subsystems, and the satellite engineer knows a lot of all the subsystems of the satellite. But when something happened with a specific subsystem, there's a moment that the satellite engineer could not know how to proceed. So this is the moment when the satellite engineer calls a satellite subsystem engineer, which is another engineer more specialized in each subsystem of the satellite. So it's another very important activity too. And we have the flight dynamic systems. In this particular case is where I'm working, is the part that I work in the Space Operations Center. The flight dynamics engineer perform the orbit determination, the maneuver computations to station keeping, collision avoidance. In fact, we have a lot of debris, a lot of satellites in space, and we perform with a very good frequency some collision avoidance maneuvers. And we have the satellite operators too. So the satellite operator is the person who stays in direct contact with the satellite, let's say, because the satellite operator is the person who sends the telecommands to receive the telemetry, and is another very important part of the operation too. Usually the satellite operators are technicians. We have the power and the air conditioning system. It's another part which is sometimes neglected in some way, but if we lose our power, we cannot continue our operation. And the air conditioning system is another very important part too, because we are talking about RF equipments, and usually they generate a lot of heat, and if we do not control this heat, this temperature, everything will fail. So it's something very important too. We have the model-based systems engineering. So here we are talking about simulations. We do simulations every time. Every single operation that we're gonna do, that we're gonna perform in our satellite, we must simulate it previously to know if everything is going to happen well. So we do a lot of simulation, and we use a lot of softwares to perform this. And the security, of course, we do not want that anyone enter in our facility, or it could not be a physical enter, but somebody could hack our system. So it's something that must be very, very safe in the security part. All right, and let's move on. So I will talk a little bit more about the activities that we perform. So of course that there are several activities to guarantee the entirely space system operation. And we have the space segment part. Of course, the satellite must do a lot of things, but we have the ground segment activities too. And most of them are made in the operation center. So some of the activities, one of them is the satellite tracking. So it's something that every single space center must do. We must know where are our satellites. So we are always performing satellite tracking. And of course, that when we are talking about the geostationary satellite, it's something that it's a little bit easier to do, because the satellite is in a fixed position. So the antenna is a kind of fixed. In reality, the antenna is not entirely fixed, stopped. So the antenna performs some lateral movements to track the geostationary satellite. But you can say that you can consider that it's almost fixed. And we have the low Earth orbit satellites. And of course, we have to indeed track the satellite when the satellite's moving on. So it's one of the most important activities too. We must know where are our satellites. Then we have the orbit determination. So after we track the satellite, we just receive a lot of data about satellites position over the time. So we must take this data and generate orbits based on this data. So this is the orbit determination, something that we do. This is one of the things that I perform as a flight dynamics engineer. We have to compute satellite maneuvers after we know where the satellite. So if we have to do a station keeping maneuver or satellite collision avoidance. And of course, we send telecommands to the satellite to perform several activities, to use the payload, to perform something in the onboard software, and so on. And of course, we receive the data from the satellite, which is the telemetry. One of the most important things of this is to know how is the health of the satellite, the subsystem status. So it's another very important activity that we do basically every day, every opportunity that we have. And sometimes we have to do systems ground and space updates. So sometimes we have to perform some update of a software on board the satellite. And clearly we do a lot of updates in our systems on ground. And so it's another activity that we do a lot in the Space Operations Center. And of course, the satellite is in space to do something. So we have the satellite applications, the usage of the payload. And of course, will be different according to the satellite payload. In our case, we use our satellite to perform communications, but we could use it for different satellites to perform image acquisition, to perform weather analysis, and so on. All right, so here we already are in the conclusion. So the ground segment is a key and critical element in space operations. And as I said before, sometimes we forget that we have and that we must have a very reliable and very high availability of our ground system. And this is something very critical. As we may see, we have a lot of interdisciplinary activities. So a lot of different engineers from different areas. We have mechanical engineers, we have electrical engineers, aerospace engineers. Sometimes we think that, all right, if I want to work with satellites and space operation, I must be an aerospace engineer, and this is not real. We have a lot of different engineers, a lot of different people working together. And we have the combination of specialized professional systems, equipments, analysis tool, and complex tool chains to guarantee that our system is operating properly and that the ground segment is working well. So yeah, it's hard, but we can do it, and we can do it here in Brazil. So that's it. That is my presentation. And unfortunately, we do not have much time to stay here, but that's it. Thank you, guys.
Thank you so much, Ricardo. And I want to thank you for your time, despite the technical issue that you had. You gave a brilliant presentation. It's very interesting to understand all of your work and this part of the ground segment and the COMAI operations. It's very interesting. I just want to see and read if you have any questions from our YouTube viewers. So let me see if we have any questions. I don't think that we have questions. So I want to thank you again in name of the Pion and LASC team for your presence and of course for your time. And I'm sure that we will talk a lot about space and about SGDC, about Latin American Space Challenge, Moon, the Moon race. Today, Paulo Vasconcelos from Brazilian Space Agency talked about the goal to put a rover in the moon, a Brazilian rover. So I think that we have a lot of things happening in the Brazilian space sector, and of course you working in the COMAI, and of course is a founder of the Pequeno Passo, is an important piece for the dissemination of the space culture and space information. So thank you so much.
Okay, Calvin, thank you for the invitation. Thank you for the opportunity. And I hope to keep in contact. And again, congratulations to this event. It's awesome. And see you soon. Stay safe.
See you soon. Stay safe also. Thank you.
Bye-bye.